Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Al Munir High School e-learning system. Class 9. This is your chemistry lecture. Today we are going to start our unit number 2. This is the title page of your chemistry book for class 9. Topic of second chapter, unit number 2 is structure of atoms. Yes students, we all know about the atoms. In the introduction he told you that ancient Greek philosopher Democritus suggested that matter is composed of tiny indivisible particles called atoms. So this is the definition of atom. The name atom was derived from the Latin word atomus, means indivisible. So in the beginning of 19th century, John Dalton put forward the first atomic theory. So in this chapter we are going to study about some theories and experiments on these atoms and its particles. Electron, proton and neutron. According to Dalton, an atom is an indivisible hard dense sphere. Atoms of the same element are alike. They combine in different ways to form compounds in the light of Dalton's atomic theory. Scientists perform a series of experiments, but in the late 180s and 90s, scientists discovered new subatomic particles, protons, electrons, and they represented the plum pudding theory, which are based upon these observations of Thomson. He postulated that atoms were solid structures of positively charged with tiny negatively charged particles stuck inside. So it is like a plums in the pudding. So this theory is known as plum pudding theory. First of all, the discovery of electron cathode rays. In 1895, Sir William Crookes performed experiments by passing electric current through gases in a discharge tube at very low pressure. He took a glass tube fitted with two metallic electrodes which were connected to a very high voltage battery. So here we have the battery and these are the two electrodes. The pressure inside this tube was kept 10 power minus 4 atm. When high voltage current was passed through the gas, shiny rays were emitted from the cathode which traveled towards the anode. So here it shows in this figure, these are rays will be known as the cathode rays. What were the properties of these rays? These rays travel in straight line perpendicular to the cathode surface. They can cast a sharp shadow of an opaque. They are deflected towards positive plate. They raise temperature of the body. J.J. Thomson discovered their charge per mass E/m ratio. Light is produced when these rays hit the walls of the discharge tube. It was found that the same type of rays were emitted no matter which gas and which cathode was used in the discharge tube, and they were given the name of electrons. Next we have the discovery of protons. In 1886, Goldstein observed that in addition to cathode rays, other rays were also present in the discharge tube, and these rays were traveling in opposite direction to cathode rays. So he gave the name the canal rays. So he called these rays as canal rays. So here we have the picture which shows, diagram shows the canal rays. What were the properties of these rays? Yes, these rays travel in straight lines in a direction opposite to the cathode rays. Their deflection in electric and magnetic field proved that these are positively charged. The nature of canal rays depends upon the nature of gas present in the discharge tube, and these rays do not originate from the anode. So here it shows that in fact these rays are produced when the cathode rays or electrons collide with the residual gas molecules present in a discharge tube and ionize them as follows. So this equation shows the ionization. Mass of these particles was found equal to that of a proton or simple multiple of it. Next we have the discovery of neutrons. Rutherford observed that atomic mass of the element could not be explained on the basis of the masses of electron and proton only. He predicted in 19 20 that some neutral particles also present having mass equal to that of proton must be present in an atom. So eventually in 1932 Chadwick discovered neutron when he bombarded alpha particles on a beryllium target. So here we have Be, beryllium. So here we have the helium particles. When they bombarded alpha particles on it, these radiations were called the neutrons. Properties were: neutrons carry no charge, they are highly penetrating, and mass of these particles was nearly equal to the mass of a proton. What Rutherford represented? Rutherford presented an atomic model. Here we have this model. Rutherford performed gold foil experiment. So these yellow parts shows the gold foil to understand how negative and positive charges could coexist in an atom. He bombarded alpha particles on a 0.0004 centimeter thick gold foil. Alpha particles are emitted by radioactive elements like radium and polonium. These are actually helium nuclei. They can penetrate through matter to some extent. So this picture shows it. What were the observations? Almost all the particles passed through the foil undeflected. Out of 20,000 particles, only a few were deflected. Results of the experiment keeping in view. Here we have the results of this his experiment. Since most of the particles passed through the foil undeflected, therefore most of the volume occupied by an atom is empty. The deflection of a few particles proved that there is a center of a positive charges in an atom, which is called nucleus of an atom. The complete rebounds of a few particles show that the nucleus is very dense and hard. Since a few particles were deflected, it shows that the size of the nucleus is very small. The electrons revolve around the nucleus. An atom is as a whole is a neutral, and except electrons, all other fundamental particles that lie within the nucleus are known as nucleons. What were the defects? According to classical theory of radiation, electrons, being the charged particles, should release or emit energy continuously, and they should ultimately fall into the nucleus. If the electrons emit energy continuously, they should form a continuous spectrum, but in fact line spectrum was observed. Next we have the Bohrs atomic model. Keeping in view in defects of the Rutherford atomic model, Niels Bohr presented another model of an atom in 1913. The quantum theory of Max Planck was used as a foundation of this model. According to Bohr's model, revolving electron in an atom does not observe or emit energy continuously. The energy of a revolving electron is quantized as it revolves only in orbits of fixed energy called energy levels. What are the postulates of his theory? The hydrogen atom consists of a tiny nucleus, and electrons are revolving in one of the circular orbits of radius r around the nucleus. Each orbit has a fixed energy that is quantized. As long as electron remains in a particular orbit, it does not radiate or absorb energy. When an electron jumps from lower orbit to higher orbit, it absorbs energy, and when it jumps from higher orbit to lower orbit, it radiates energy. So here we have the formula. Electron can revolve only in orbits of a fixed angular momentum. mvr shows the momentum, which is nh over 2 pi. Here we have the summary of the differences of Rutherford and Bohr's atomic model, the same as we have studied above. Next, our topic is electronic configuration. We have learned about the structure of the atom. It consists of tiny nucleus lying in the center and electrons revolving around the nucleus. So students, we all know about this structure of an atom. Here we have the energy levels, which are represented by n levels, 1, 2, 3 and so on. They are designated by the alphabets K, L, M, N. A shell closer to the nucleus is of minimum energy. K shell is the closest to the nucleus. The energy of shells increases from K shell onwards. So first energy level is the K shell. Here we have the K shell. Second energy level L shell. Third energy level is M shell, and fourth energy level is N shell. In simple words, shells are the main energy levels that electrons can occupy. So shells are represented by circles around the nucleus. They are counted from the center to outward. So this table shows the and values, their shells and their subshells. What is the electronic configuration of first 18 elements? The distribution of electrons around the nucleus in various shells and subshells according to their increasing energy is called electronic configuration. The most stable or ground state electronic configuration of an atom is the one in which electrons are present in the lowest energy possible energy level. The electrons fill the shells in order of their increasing energy. Lower energy level is occupied first, then the high energy level, and so on. The maximum capacity of shells to accommodate the electrons is as following. K, L, M shows different energy levels, can accommodate 2, 8 and 18 electrons. So first of all, we have this example 2.1. Write the electronic configuration of an element having 11 electrons. So keep in mind that all electrons do not have the same energy, therefore they are accommodated in different shells according to increasing energy and capacity of the shell. First of all, the electrons will go into K shell, which has minimum energy. It can accommodate 2 electrons. After it, it will go into L shell. It can accommodate 8 electrons, and so on. So example 1, 2.1, 2.2, 3 is the same as we have studied above. So this table shows the elements, their symbols, their atomic numbers and their electronic configuration. You have to read it in detail. Our last topic is isotopes. What is isotopes? Isotopes are defined as the atoms of an element that have same atomic number but different mass number. They have same electronic configuration and number of protons, but they differ in number of neutrons. Isotopes have similar chemical properties. Examples are isotopes of hydrogen. There are 3 isotopes of hydrogen: protium, deuterium and tritium. Next we have the example of isotopes of carbon. Carbon also have the 3 isotopes, carbon 1, 2 and 3, which have same atomic number but different atomic masses. Isotopes of chlorine, uranium. So this table shows the atomic symbols, atomic number, mass number, number of protons and number of neutrons. Next we have the application uses of isotopes. Yes, we use isotopes in radiotherapy for the treatment of cancer. Isotopes of P32 and SR90 are used for the treatment of the skin cancer. Tracer for diagnosis and medicine. Yes, it is also used as a tracer in medicine to diagnose the presence of tumor in the human body. Isotopes of iodine 131 are used for the diagnosis of goiter in thyroid glands. Archaeological and geological uses. Yes, an important method of age determination of old carbon containing objects by measuring the radioactivity of C14 in them is called radiocarbon dating or simply carbon dating. The radioisotopes are used in a chemical reaction to follow a radioactive element during the reaction and ultimately to determine the structure. C14 is used to label CO2. Also, it is also used in power generation. Radioactive isotopes are used to generate electricity by carrying out controlled nuclear fission reactions in nuclear reactors. For example, when U-235 is bombarded with slow moving neutrons, the uranium nucleus breaks up to produce barium 139 and krypton 94 and 3 neutrons. So students, this was our last topic. Next we have the summary and the key points of unit number 2. Next we have the exercise, multiple choice questions. 4 options are given. We have to select the correct one. Which one of the following results in the discovery of protons? Which one of the following is the most penetrating? The concept of orbit was used by. Which one of the following shell consists of 3 subshells? Which radioisotopes is used for the diagnosis of tumor in the body? When U-235 breaks up, it produces, so the subshell has deuterium is used to make. The isotope C12 is present in the absence of, and who discovered the protons? You have to mark it according to your as it is given in your book. Also mark the short question answers and the long questions of unit number 2. Thank you. Allah Hafiz.